Before starting with solar irradiance simulation, we need to select which part of the project we want to simulate. In solar irradiance section there is an sensor grid option. This will ask you to pick start point of the rectangular grid, click on it in the model space. Then pick end point diagonally to first point as if you were making a rectangle. This will make a rectangle sensor grid like on the image on the right. This area will be affected by the simulation. If you need to correct size, shape or placement of the grid, select the grid on the drawing and use stretching points on it to stretch, add vertex or convert to arc. After you have created sensor grid, you can proceed to run irradiance simulation. Through applying certain parameters and options, we can optimize our PV system setting to have maximum usage of a solar plant. In solar irradiance section there is a simulation option. This will open a pop-up window as shown on the right. In order to get the result which are based on our location, we need to load the weather file into our configuration. We can do so by going to https://energyplus.net/. When we navigate to this page, we need to go to the weather section. On the new opened page, navigate to the location of our project, PV plant. Going step by step, region, country, town, we navigate to the nearest to our project location. You can also search needed location on the map placed below, or search needed location through the searching tool by name. We can to download the EPW weather file. This file contains necessary information regarding our project. Once the weather file has been downloaded, we need to upload it to the Virto-Solar. Click on the ellipsis. Navigate to the location of your file. Select the .epw file and click Open. This will upload the weather information to your DWG file. There are a lot of parameters that we can change in order to get the results that we need. Start-end month allows to edit the period of time that we want to simulate. Keep in mind that the longer the period, the more it will take the software to process the information. Sensor grid boundary, we need to select with one of the options which boundaries we want to simulate. Mode, as we can see there are two options in this section. Surface, it will analyze the ground surface in the simulation. Modules, it will analyze the modules in the simulation. If we select modules option, we need to specify a number of horizontal and vertical cells of module which will determine the size of one sensor element in simulation. If we select surface option, we need to specify sensor size parameter which influence on the simulation progress. Sensor is almost like pixel, so sensor size means the size of sensor square side. The bigger sensor is, the smaller resolution will be on the drawing, and vice versa. Sensor offset height is the height on which the radiance surface will be calculated and created. If the modules on the racks would be elevated 80 mm above the ground, then we can set the sensor offset height to 80. Show output only on roof surfaces, no available for ground mount systems. Show percentage per module when ticked. This option shows us percentage of solar irradiance per module. Output section has different options. Hatch, this option lets us select the visual representation of our simulation that can be either a solid or a 45-degree hatch. Output in percent, when this is ticked the output is shown in percentage, when is unticked it shows the output in kWh. Threshold, we can set the percentage that we want to show. Output XREF allows us to save an XREF file of our solar irradiance. Selecting settings, we will get the window as shown on the right. There are additional options to the XREF file location and naming which we need to determine reference type, path type, XREF names, modules file name, folder to save the file. Also we can set the color grading scale for radiation visualization on the drawing. Moving the slider, we can change the value of lower and upper limit of output percentage for which color grading will be done. It can help to show a small difference in solar radiation on the drawing. Once we set all the parameter, we can then proceed to making the simulation. To start, just click on Start button in the Irradiance window. Congratulations, we have made a radiation simulation. If you need to make radiance surface on drawing less brightful, you can set its transparency. In solar irradiance section there is an transparency option. In the command line or in the cursor line, enter the value of transparency in percent from 0 to 95 you want, and click enter, space. Notice that the bigger the transparency value on your drawing is, the less bright it will be. For our case, we set 50% transparency. To free drawing space from excess visual information, we can set the percentage of solar radiation that we want to show. In Solar Irradiance section, there is an threshold option. This will open a pop-up window where we need to select options for our threshold setting. In the Irradiance section, there are such options. Irradiance on roof surfaces, threshold settings will be adjusted only to roof surfaces. Irradiance on solar modules, threshold settings will be adjusted only to solar modules surfaces. Erase modules below cut-off percentage modules which will have a radiation value lower than threshold value will be erased from drawing. Erase percentage per module values, allows do not show values of percentage for every module. It's available to untick only when irradiance on solar modules option selected. %, or kilowatt-hour per square meter. Tick the units in what cut-off threshold will be set and enter its value. In our case it will be 98%. In the grids section we can select grids for which we want to set a threshold. After all parameters were set, click on Start button. Radiance surface will be cutted with threshold value we have set, image on the right. To erase radiance surface from the drawing space we can use Delete option. In Solar Irradiance section there is an Delete option. The software will ask you to pick point inside grid we want to clear, click on the model space. After you click on the grids asterisk you want to delete, click Enter, space. Selected grids will be deleted.